Hi, in this session we will consider the isometric projections of compound objects. And in the first problem we have a frustum of a square pyramid and it is resting on a square slab. The dimensions of the square slab and the frustum of the cone are given. And first of all we have to draw the simple plan and the elevation. The slab is represented as A, B, C, D, E, F, G and H, and the frustum of the cone is represented as P, Q, R, S, and the top surface is T, T dash, U dash, V dash and W dash. This height is given, so you fix a section plane. After drawing the square pyramid, you have to fix a section plane. You will get the intersection here, project downward and obtain T, U, V and W. So this portion is the frustum of the square pyramid, whereas the outer portion denotes the corner points of the square slab. After that, here we have to draw the isometric projection. While drawing isometric projection, you have to take isometric scale. The points in the isometric projection will be 0.816 times the actual length. Our first step is enclosing the object in a square cubical cage, a glass cage, and let us enclose it in a cubical cage and let the points be 1, 2, 3, 4 and 5, 6, 7 and 8. Here the base points are 1, 2, 3, 4 and the top points are 5, 5 dash, 6 dash, 7 dash and 8 dash. After that, you have to draw the isometric projection of the outer cage. First let us fix the first point 1. After marking point 1, you have to draw two 30-degree lines. These lines are of 30-degree inclination. After drawing this 30-degree line, you have to mark the isometric equivalent of this distance. That is, this distance is 60 mm. So 60 multiplied by 0.816 gives 49 mm. And you take 49 mm in your compass and here you have to mark that distance. This distance is the isometric equivalent of 60, that is 49 mm. The same dimension can be marked here and you will get another point, and this is point 2 and this is point 4. For obtaining point 3, you have to draw two 30-degree lines, one from point 4, you are drawing a line like this and drawing another 30-degree line from point 2 and intersecting the previous 30-degree line, and that intersection is point 3. After that, you have to draw vertical projectiles from 1, 2, 3 and 4, and after drawing you have to mark the isometric equivalent of this total height. The total height of the object, that is, the slab dimension is 15 mm plus the height of the first term. The height of the first term is given. It is 30 mm. So 30 plus 15, that is 45 mm. 45 mm is the actual height of the compound object. So convert 45 to the isometric equivalent. On converting this to isometric equivalent, you will get around 37 mm. So take 37 mm in your compass and have to take 37 mm in your compass, and with 1 hour center you have to intersect here so that you will get the first point. Similarly, with 2 hour center, intersect and you will get point 6. Point 3 hour center and intersecting, and you will get point 3. And 4 hour center and intersecting, and you will get point 8. So we got 5, 6, 7 and 8. After that, you join these points by means of straight lines. And these lines must be thin lines. And these thin lines denotes the surrounding glass cage. Our object is centrally placed in this cage. And first of all, let us consider the square slab portion. The point A of the square slab is coinciding with point 1. So this is point capital A. Similarly, point B is coinciding with point 2. So that is point B. And here we have point C, and this is point D. So A, B, C, D are the position of the base. Now we have to locate the top points of the bottom square slab, and the height of the square slab is given. It is 15 mm. So you have to convert to the corresponding value. At here you will, after converting, you will get around 12 mm as the height. So take 12 mm in your compass, and with 1 hour center, this length is 12 mm, which is equal to the isometric equivalent of this height. This is 15 mm and it is given. Convert to isometric scale so that you will get 12 mm as the height. Take 12 mm in your compass and intersect here, here, here and here, so that we will get 4 points. One point here, another one here, another one here, and another one here. This height is the isometric equivalent of the height of the square slab, that is 15 mm. 15 multiplied by 0.816 is 12, approximately 12 mm. After that, you have to connect these points by means of straight lines. Connecting this. And this portion denotes the top face of the square slab. This is point capital E. This is F. This is G. And this is H. So that completes the base portion of our compound object. Now, the first term of the square pyramid is centrally placed over this slab. So we have to fix the base portion of the square slab over this surface. For that, here the base portion is denoted as P, Q, R and S. Consider point P. point P is this much distance away from this line, that is line 1, 4, and this much distance away from line 1, 2. So let us draw two grid lines. Say, like this. I'm drawing a line like this and another line like this, so that we will get a distance here and another distance here. You find this distance. Let us measure that distance. It is around, that distance will be 10 mm. And you convert that distance to the isometric equivalent. 10 multiplied by 0.816. That is around 8 mm. Take 8 mm. So this distance is 10 mm away from line 1, 1, 4 and 10 mm away from 1, 2. That is this distance. You take the corresponding distance from here and here. That can be marked here. Let us mark that. That is 8 mm. 8 mm is the isometric equivalent of the offset. Let us mark that. 8 mm and another 8 mm in the opposite direction. This is also 8 mm. So 2 8 mm points. Now you take your, so what is 8 mm? That this point P is located 8 mm away from 1, 4 and 8 mm, not 8 mm, that is 10 mm, 10 mm away from 1, 4 and 10 mm away from 1, 2. And after converting to isometric scale, it is 8 mm. So take 8 mm from 1, 4. This line, the line corresponds to the top surface is this one. So from this line take 8 mm and another 8 mm from this line. After that, you take your 30-degree set square and draw a line like this, and another 30-degree line like this, and these two 30-degree lines will intersect here. That is the position of point capital P. Now, after locating point P, let us locate point Q. Point Q is located in these two grid lines. Let us draw the grid lines. It is the intersection of this grid line and this grid line. We have already drawn this grid line. Let us draw the grid line connecting these two points. It is also 10 mm away from this side, that is the edge connecting 2 and 3. Let us draw that. This is 2 and this is 3, and we have to consider the top surface, and this distance is 8 mm. This is 8 mm and another 8 mm from point F. So that you will get a point somewhere here. Let us draw another 30-degree line. so that you will get an intersection somewhere here. That is the position of point capital Q. Then we have to fix point R. For that, we will consider these two grid lines. Point R is the intersection of this line and this line. These two lines are 8 mm away from this side and this side. Let us, 8 mm means the converted distance. Actually it is 10 mm. 10 multiplied by 0.816 gives 8 mm. So take 8 mm and you have to mark that distance. It is 8 mm. From here is 8 mm, and through that we have to draw another 30-degree line, so that you will get a line like this. And this line is intersecting here. That is point capital R, and this line is intersecting here, and that is capital S. So we got P, Q, R and S. Now what next? We have to find the position of T, U, V and W, and that is located on this plane. And for locating that, we have to consider the corresponding intersections. Point T is the intersection of this line and this line. This distance is 20 mm. So 20 multiplied by 0.816 gives around 16 mm. So take 16 mm and mark that distance here. 16 mm, and thus by taking 16 mm, you see this. These point T, U, V and W are located in grid lines which are 20 mm away from each side. So let us draw the corresponding grid lines. So after converting 20 to isometric scale, we will get 16 mm. So we mark 16 mm in these two sides and another 16 mm in the other side. Let us draw that. 16 mm here, 16 mm here, 16 mm from here, and another 16 mm here, so that we will get some points. Let's draw that 16 mm. This is also 16 mm. And let us join these points so that we get a pattern like this. And we got the grid lines over the top surface, and this point is point capital T. This is point capital U. This is capital V, and this will be capital W. After that, we have to connect these points. First of all, let us consider the border, the boundary lines. Let's connect P and S, P and Q, then Q and U, U and V, V and W, then S and W. Then here the top surface of the frustum is visible. So this is firm line. This lateral edge is visible. Draw that. And here, after drawing this, you have to draw the hidden lines. Some lines are hidden behind the object. Let us erase the unnecessary lines. And let us connect S and R by means of dotted lines. Then Q and R. S and R is dotted line. Q and R also is a dotted line. And the portion, the slab which is located behind the object is, the edges should be dotted. Let us make that dotted line. Up to this portion it is firm. After that it is dotted because it is hidden behind the frustum. And that completes our first problem. This is dotted line. And that is the end of our first problem. And after drawing the isometric projection, you have to mark the dimensions of this object. The actual dimensions of the object must be marked in the simple plan and elevation. And that is the end. And thank you.